All right, students, we're going to do lesson 5A, ratio reasoning, converting customary units. Customary units are like feet, inches, pints, quarts, anything that's got a unit to it. And there's English units, U.S. customary units, and there's metric. We're not going to work with metric just yet, but we will in a day or two. But right now we're just going to work with U.S. customary. Okay, so in this first problem, if 6.5 feet of snow were to fall in 24 hours, would the 1921 record be broken? There are 12 inches in a foot. Now this is a fact. This is a fact. 12 inches equals 1 foot. Okay, and you'll see me write it. 12 inches equals 1 foot. Okay, in this picture it says that inches fell in 24 hours, and this said feet fell in 24 hours. So we need to change this 6.5 feet to inches so that we can compare. So I'm going to come right down here, and we're going to take 6.5 feet, FT, and we're going to change that to inches. And I'm going to do this by writing it as a fraction. I'm going to write it over 1, and I'm going to multiply it by the fact that there's 12 inches in 1 foot. Now, please learn this from me easy, because I'm telling you this does not have to be hard. There's 2 halves to this. Here's a half and here's a half. Put the one in the bottom that you have in the top. You have feet in the top as a unit. So we want to put the 1 foot portion of this fact in the denominator. Means the 12 inches has to go in the numerator. Now, just like canceling common factors, feet cancel out. And we do what it says to do. And these parentheses are multiplication. So I'm going to take 6.5 and multiply it times 12. 6.5 times 12. And this is called converting. We're converting from feet to inches, and you get 78. Now, whatever unit you've not canceled out is the unit that's on your answer. 78 inches. Okay? This is a fact right here. This is what we started with, and we use a fact to turn it from feet to inches. Okay? And there's some of these facts that you need to get memorized, just like you needed to memorize your multiplication facts. Okay, but we didn't answer the question. In 1921, it was 75.8 inches, and now it's 78 inches. So was the record broken? Yes, the record was broken, because 78 is greater than 75.8. It was 75.8 in 1921, and then it was 78 now. So yes, the record was broken. But notice that we couldn't compare 6.5 feet to 75.8 inches. We had to compare inches to inches. So that's why it had to be changed. Converted is the word I like to use. Okay, now let's make sense and persevere. How many feet of snow would need to fall to Silver Lake, Colorado to break the 1921 24-hour snowfall record from 1921? Okay, so we need how many feet of snow. So I need to take the 75.8 inches and see where the border line is. Let's take the 75.8 inches and let's turn that into feet. So this time we're going to multiply by and put the 12 inches in the denominator, because I need inches to cancel out, and the 1 foot in the top. Now once again, 12 inches equals 1 foot. The 1 stays on the foot, the 12 stays on the inches. But I want the 12 inches in the denominator this time because I want inches to cancel out. So this time I'm going to be taking 75.8 and dividing by 12 because we're changing from inches to feet. So it's 6.32 feet. Now let's answer the question. How many feet of snow would need to fall? Well, I need more than 6.32 feet to break the record. Okay? And all we did, we took what it was in inches in 1921, changed that to feet, and then if we wanted to break that record, it would have to be a little more than that. All right, let's go to page 316, example number 1. Now, I want you to look at this little chart. These are all lengths, customary units of length. These are all facts. They won't change. They are what they are, and you need to memorize them. There is 1 foot is 12 inches. There's 3 feet in a yard. There's 36 inches in a yard. There's 5,280 feet in a mile. There's 1,760 yards in a mile. Teachers, please make an anchor chart and put these up there and drill your kids on them when they walk in the door every day. Okay? And we're going to use these facts to solve problems, so you have to know them. All right. The problem right here. The sidewalk in front of a store is 4.5 feet wide. The city regulations establish a maximum of 66 inches. Does the sidewalk meet the city regulation? City regulations establish a maximum width for sidewalks of 66 inches. Does the sidewalk meet the city regulation? The sidewalk is this, and we want to know if that's okay. So we need to take 4.5 feet, and I'm going to do it my way. Let me see. Let's do it my way right here. We're going to take 4.5 feet, and we're going to multiply that by, that's in the numerator, we're going to multiply it by, in 1 foot, there's 12 inches. And mark out our feet, because we're changing it from feet to inches. We're going to take 4.5, we're going to multiply it by 12. And I get 54 inches. My way. And it says the maximum width for the sidewalks is 66 inch maximum. Well, we didn't go over that. So we're okay. It meets regulations. Okay? Now there's 2 other ways. Well, one other way. One other way right here. It says we're going to write the width of the sidewalk in inches. Identify the conversion rate. That's this one right here, the fact. Find an equivalent rate. And they ended up with 54 in 4.5 feet. They took their fact and they said, we want 4.5 feet instead of 1 foot. So they multiplied top and bottom by 4.5. And there's their answer, 54 inches right there. Now, look at another way. Use dimensional analysis to convert measures by including measurement units when you multiply by a conversion factor. A conversion factor is a rate that compares equivalent measures. Now, does this one right here look more like what I did or this way? I took the 4.5 feet and I multiplied and I just used parentheses instead of that X right there. Okay, so this is what I use. It's called dimensional analysis. Okay? All right. This is the one I prefer that you learn and use. And you'll use this or should be using this a lot in science class also. All right. Let's go to example number 2. Jonah has 15 gallons of water for a camping trip. How many quarts of water does he have? Once again, teachers need an anchor chart with this on there, and your students need to be learning and memorizing these customary units. Okay? There's 4 quarts in a gallon, if you didn't know that. He wants 15 gallons. So here's one way to do it. Multiply 1 gallon times 15, so 4 quarts times 15 is 60 quarts. The way I want you to do is this one right here. Take 15 gallons and multiply, here it is, right here. Multiply 4 quarts and 1 gallon, cancel out your gallons, and you're left with quarts. So it's 15 times 4. When there's just a whole number on here, it's like it's in the numerator. Okay, this is the method I prefer you learn. All right, let's go to the try it right here, and we're going to use dimensional analysis. His recipe says to use 2.5 tablespoons of sugar. How many teaspoons is this? So we're going to write down our 2.5 tablespoons, and the abbreviation for tablespoons is a capital T, supposed to be, and TSP is teaspoon. They wrote it out, but okay, so I want to change tablespoons to teaspoons. So I need this one right here. So I'm going to multiply, and I want the tablespoon part, so I want the 1 tablespoon in the bottom. I want the 3 TSP, 3 teaspoons, in the top. So I just need to take 2.5 and multiply it times 3, which is 7.5. And now it's teaspoons. We changed tablespoons to teaspoons, and we need to mark those out. We changed tablespoons to teaspoons by multiplying by the unit multiplier, or the conversion factor, or the fact. Conversion factor. Okay, let's go to example 3. The alpine pika is a small mammal in the rabbit family. How much does the alpine pika weigh in pounds? The number of ounces in the conversion rate is greater than the number of ounces that the pika weighs. Use division to find the equivalent rate. So we have ounces in a pound, and we have pounds in a ton. Okay? Weighs 10 ounces. Yes? So I'm going to use this way right here. I'm going to start with the 10 ounces that we weigh, and I'm going to change it to pounds. So in 1 pound, there's 16 ounces. The ounces go away. So it's 10 divided by 16, or 0.625 pounds. Okay? Let's go to the try it. That one was done for you. This next one is not. Stella weighs 3.3 tons. How many pounds is that? So we're going to start with 3.3 tons. And we're going to look at our chart. In 1 ton, there's 2,000 pounds. You need to remember that. So we're going to multiply in 1 ton. The 1 ton's got to be on the bottom because tons have to cancel. So that puts the 2,000 pounds in the top. So we're going to take 3.3 and multiply by 2,000. And we get 6,600 pounds. 6,600 pounds. Okay? All right. Key concept, top of the page. You can convert customary measures by finding an equivalent rate or by using dimensional analysis. We would like to use dimensional analysis. That's the one I'm shooting for you to learn. Okay? And remember, we're going to start trying to memorize some of these. Number 1, how can you use ratios to convert? I don't even know if I want you to do all these questions or not. Let me see. Let's skip down to number 2. We're not going to do that one. Let's go to number 2. It's a good question. What is a conversion factor that relates miles to yards? Look up at the top of the page. I could say that in 1 mile there's 1,760 yards, or I could use it that way, or I could say there's 1,760 yards in 1 mile. It depends on what I'm starting with, which way I use it. Every one of these unit multipliers can be used one way or flipped over. Okay, let's look at number 3. Jenna used the conversion factor 1 ton is 2,000 pounds to convert 50 tons. If you start with 50 tons, what should you multiply that by? Well, the 1 ton, it's got to be in the bottom, and the 2,000 pounds, LB is abbreviation for pounds, and don't ask me why, because I don't know. It doesn't start with a P, but I don't know. LB is abbreviation for pounds. So, no, it's upside down. It should be like this. Okay? She used it the wrong way. She had her 1 ton in the numerator and 2,000 pounds in the denominator, and you can't do that. She had it upside down. Okay, let me see if they gave you, how can you use the conversion rates of ounces to cups and cups to pint to find ounces in a pint? You would just put 2 unit multipliers in there. Let's go look right over here. Ounces to cups, cups to pints. Ounces to cups, and then cups to pints. So you'd have to use 2 of them. Let's see. Ounces to cups, and then cups to pints. So you'd use 1 here, use 1 here, and you just keep lining them up and keep going. They didn't give us anything to convert, so we're going to skip over that one. Now let's go to number 5. Convert 27 inches to yards. So we're going to start with 27 inches. We're going to multiply that by inches in a yard. Look right up above. There's 36 inches in 1 yard. The 36 inches has to go in the denominator because it's got to cancel with that unit right there. And 1 yard goes in the numerator. So since our number is 1 is in the denominator and 1 is in the numerator, we have to divide. So it's 27 divided by 36. And I get 0.75 yards. Okay? Again, I'm going to use dimensional analysis on number 6. Use dimensional analysis to change 1.8 pounds to ounces. So 1.8 pounds. I want to change that to ounces. Let's turn our paper back over. Pounds to ounces. 16 ounces in a pound. It didn't tell you up here, it told you right down here. See it? 16 ounces in a pound. I thought it was in that chart, but it's not. Okay, 16 OZs equals 1 LB. 16 ounces in a pound. So the 1 pound's got to go on the bottom, and the 16 ounces is in the numerator. So we're going to multiply 1.8 times 16. and we get 28.8. And that's OZs. Pounds are gone. Remember, abbreviation for pound is LB. Ounces is OZ. There's not a Z in the word ounce, and there's not a P in that abbreviation. So don't ask me why those are what they are, but they just are. That's all I can tell you on that. Probably has something to do with whatever language it was written in to begin with. All right, number 7. Sam is tripling. Tripling means times 3. A recipe for an organic cleaning solution. The new recipe calls for 15 teaspoons of orange oil. To find how many tablespoons this is, Sam converted this way. So he took 15 teaspoons and he multiplied it times this right here. Is it right? Can you cancel a numerator with a numerator? So the answer is no. His unit multiplier is upside down. Or his fact is upside down. His conversion fact is upside down. Okay. We're going to take 2 days to work on this lesson because I want you to get this dimensional analysis down really good. So for the rest of today, I want you working on practice and problem solving. You may have to get some lined paper in order to have enough room to do this, because you got to take, you're changing pints to cups. So you got to start with your 5 pints. You got to go find your fact. 1 pint is 2 cups, and you got to have room to do this. The 1 pint's got to go in the bottom, and the 2 cups have got to go in the top. So it's 5 times 2, so it is 10 cups. You got to have room to do this. You may run out of room on some of these. Okay, so I want you to work on page 319, and then on the back side 320, and get as many of these completed as you can on dimensional analysis. We'll do a little more of this tomorrow because it's very important that you learn how to do this. Anyway, in my opinion, it is. Okay, so there's your first half of lesson 5-8. Spend the rest of your time working problems with your classroom teacher. Good luck, and I'll see you next time.